For lesson 8 of module 3, we're going to start on exercise number 2, and we're focusing more on whether these are similar triangles or not and what is making them similar triangles. So if we look, we have triangle ABC right here, and we have triangle A prime, B prime, and C prime. And if we look at the side lengths of this, because it's not being dilated from the origin, we can see that side length for AB is 2 units. We have A prime, B prime, that is 1, 2, 3, 4, 5, 6 units. And over here, we have BC, that is 1, 2, 3 units. And B prime, C prime is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So B prime, C prime equals 9 units. So we had learned before that if we take the original measurement and we multiply it by R, which is our scale factor, we will get our new measurement. So if we have 2, we think about what we would multiply 2 by to get 6. This one, our scale factor would be 3. And here, if this is a similar triangle, we would also multiply 3 by 3 to get 9. And that is true. So R is 3. So we know that these are similar because they have the same scale factor. This one, number 3, are the two triangles shown below similar? If so, describe a sequence that would map it, but we're not going to worry about the sequence right now. We're worrying more about if they're similar and how we know they're similar. So a highlighter might be helpful with this, just to highlight and make sure we have the corresponding sides that are set. So if we start with side BC over here, and we need to find B prime, C prime over here to match it. B prime, C prime would be our new one, over BC would give us our scale factor. So BC was 4 units. B prime, C prime is 4 units. BC was 6 units, which would be 4/6, and that reduces down to 2/3. And here we have AC, and we have A prime, C prime. Which would be 12 units over 18 units. Both of these can be divided by 6. And that results with 2/3 being our answer. And AB and A prime, B prime would be our last side to see the relationship for. And that would be 10 over 15. Both can be divided by 5. So we have 2/3. So yes, these are similar because the sides have the same scale factor of 2/3. So if you want to pause the video and catch up with that, you can. And then I'll have you start working more independently on the next ones with a little bit of guidance. So my explanation is yes, they are similar because all of the sides are using a scale factor of 2/3. As far as number 4 goes, I'm going to recommend that you identify the corresponding sides first, and then we'll use those measurements to set up the ratios. So pause the video, identify the side of the original, which would be over here, and the sides of the dilated or enlarged figure, which would be over here. So pause the video. I will identify them now, and then it'll pop up after when you start the video again. Looking at this, A prime, B prime was 10.67 units, 10 and 67 hundredths units, and AB was 8 units. When we divide those on the calculator, we get approximately 1 1/3. I know there are some numbers after a few threes, but we are going to assume that that's close enough. When we reduce 8 6, we get approximately 1.3 repeating. It would be 1 1/3. And the same thing here, 1 3/10 repeating. So because each of the corresponding sides has a similar scale factor that's being used, we can say that these are similar for the same reason before. Our scale factor for this would be 1 1/3 or 4/3 to show that they are similar. As independent practice, you're going to be doing number 4 and number 5 on the problem set, and be sure to show your work for those so that if we need to, we can go back and check it and see exactly how you got your answer. And I'm also going to recommend doing number 6, and be sure to label your height and your width, because that'll help you set up your ratios for the scale factor of the sides.